Hi, welcome to this demo. My name is Anuraj. I am an engineering technologist with Dell. Dell CSM 1.8 added support for PowerFlex NFS RWX volume. So in this demo, we are going to integrate Dell PowerFlex 4.5 with the Red Hat OpenShift 4.13 using the Dell CSM 1.8, and we'll be provisioning NFS RWX volumes from the Dell PowerFlex array using the CSM. So here we have the PowerFlex 4.5 array. So let's look into the storage pools, and we can see one storage pool is created, SP-01, and we can check the SDS connected, and we can see there is 6 SDS part of this cluster, and go to the host. In the host we can see 2 SDCs connected, and these SDCs are used for running the SDNAS. Now verify the NAS server. Go to the file, NAS servers, and we can see there is no NAS server created yet. So let's create one. Select the protection domain, provide the IP address of the NAS server, also provide a name for the NAS server, and provide the subnet mask, and also give the VLAN ID. Select the NFS as the protocol. Now the NAS server is successfully created. From the resources section, we can verify all the resources added to this cluster. Click on the PowerFlex system. We can see the PowerFlex MDM cluster here. And from the PowerFlex file, we can verify the SDNAS cluster. And currently, there is 2 SDNAS nodes running. And also, let's verify the file systems in this machine. So currently, there is no file systems created, and we'll be provisioning the file system using the CSM. For this demo, we also have an OpenShift cluster 4.13 with 3 master node and 3 worker node. And this cluster is not yet integrated with the Dell PowerFlex array using the CSM. So let's go to the OpenShift console. Go to the operators. In the operator hub, search for CSM and install the Dell CSM operator. So this will take some time to complete the installation of the Dell CSM operator. So we'll wait for some time and we'll resume once it is completed. Now the CSM operator is successfully installed. So let's go back to the OpenShift console, and we can create a new project for installing the CSM for PowerFlex. And I already created the configuration file for the PowerFlex array. And by using this configuration file, we can create a secret. Now let's apply this YAML file to create the secret. Now the secret is successfully created. Now we can create the CSM for the PowerFlex. So select the VxFlex OS project and create the CSM instance. So the YAML file for the CSM instance I already created, so I'll paste it here. Once verified, we can create the CSM for PowerFlex. So click on create. Now the CSM instance for the PowerFlex got installed successfully, and we can verify the same from the CLI also. So once the CSI driver got installed, we can see all the worker node SDCs got registered into the PowerFlex manager. Next, we can create the storage class for provisioning the NFS volumes from the PowerFlex. So the YAML file for creating the storage class is already created. So let's apply this storage class YAML file. Now the storage class got created successfully. Now we can create a PVC and a deployment to use that PVC. So the YAML file for the same is already created. So let's verify this YAML file. So here we can see I'm creating a PVC, and the access mode for the PVC is read write many, and the volume mode is file system, and it is using the storage class pf01-NFS. So this will be provisioning a NFS export from the PowerFlex storage array. Also from the YAML file we can see that this PVC is getting mounted inside the pod at the mount path /data, and also this pod is continuously creating a file inside that mount point in a specific format, the node name where the pod is running, hyphen the pod name, and a timestamp. So if you go into that path, we'll be able to see these files getting created. Now I'll create all this PVC and the deployment inside the default project. And let's apply this YAML file to create the deployment and the PVC. So let's verify the PVC. Now the PVC got created successfully. Also let's verify the pod status. We'll wait for some time for the pod to be in running state. Now the pod is in running state. So let's go to the PowerFlex console, and here we can see a new file system created, and also there is an NFS export created. So let's verify the NFS export, and we can see the NFS export is created successfully. As this PVC is created as a read-write mini PVC, so it is possible to mount the same NFS export into multiple pods. So let's scale this deployment from 1 replica to 3 replica. So there will be 3 different pods running for this deployment, and all these 3 pods will be mounting the same NFS export. So let's verify these pods. So we can see the pods are getting created. Once the pods are in running state, all the pods will be writing into the same NFS export, the node name and the pod name. So we can go inside the pod and we can verify the data is written by all 3 pods into the same NFS export. So now the pods are in running state. Let's go inside a pod. Move to the mount point /data and list all the files here. And we can see here the files are created by all the 3 different pods running on the 3 different worker node. Next, we will provision the RWO volumes from the PowerFlex array. So for that, let's create a storage class. And the YAML file for the storage class is already created. Let's verify the YAML file. This storage class will provision the block volume from the PowerFlex array and will create an XFS file system on top of that block volume and will be mounted into the pod, and apply this YAML file to create the storage class. Now the storage class got created successfully. Now we will provision a RWO volume and a deployment. So for that, the YAML file is already created. So let's verify this YAML file. Here we can see a PVC is getting created and the access mode of the PVC is read-write once. So that means this PVC can be mounted only onto one node, and the volume mode is file system. So this PVC will be a block volume provision from a PowerFlex, and an XFS file system will be created on top of this block volume, and then that volume will be mounted into a pod. Also we can see this PVC is getting mounted in the mount path /data inside the pod, and also this pod is continuously creating a file with the format of the node name - pod name and a timestamp. Apply this YAML file for creating the PVC and the deployment. Now the PVC is successfully created. Let's verify the status of the pod also. And we can see the pod is also in running state. Let's go to the PowerFlex console, into the volumes. So we can see a block volume got provision from the PowerFlex. As this is an RWO volume, this volume can only be mounted to a one node at a time. So let's try to scale this deployment from 1 replica to 3 replica. So now 2 more pods will be trying to mount this PVC. Verify the pod status. So we can see the status of the pods are in container creating, and these pods will remain in this state as these pods will not be able to mount those PVC. So we can get the details about this pod by running OC describe on the pod. Here also we can see the attach of the volume got failed because the volume is already attached on another pod. And this is a RWO volume, so it can only be mounted onto one node. Next, we will configure read-write many volumes using a raw block device from the PowerFlex. So for that, the storage class YAML file is already created. So let's apply this YAML file to create a storage class. Now the storage class is successfully created. Let's review the YAML file for creating the PVC and the deployment. We can see there's a PVC getting created and the access mode of the PVC is read-write many and the volume mode is block. So this will create a block volume from the PowerFlex array, and the CSI driver will not be creating any file system on top of that block device, and this block device will directly be mounted onto a pod. And also because of the access mode read-write many, this block device will be mounted onto multiple nodes at same time. Also we can see the PVC is getting mounted into the pod as a device /dev/data0, and this deployment will be deploying 3 replicas of the pods. Apply this YAML file to create the PVC and the deployment. Now verify the status of the PVC. So we can see the block RWX PVC is successfully provisioned and is in bound state. We can also see the PV. Let's verify the status of the pod, and now we can see there is 3 pods running as part of this deployment. We can verify this PV from the PowerFlex console also. Verify the block device /dev/data0 is successfully mounted onto all the 3 pods. This concludes this demo. Thank you for watching.